Okay, I am going to talk a little bit about the introductory lab, as I've already had some questions about it. This lab is a dry lab, so you don't have to actually do the experiment, whether you're an online student or face-to-face. And it is meant to get you familiar with graphing programs like Excel, Google Sheets, or Desmos if you so choose. So it's up to you to decide which program you want to find out more about and learn how to graph in it. We will be using those techniques in a couple of other labs during the semester, so I felt it was important to tackle it right at the beginning. So for this lab, you are given 3 tables with a volume versus the mass of water plus cylinder in table 1. In table 2 is glycerol plus cylinder, and in table 3 is methanol plus cylinder. I want you to graph them exactly the way they are, so do not try to figure out what is just water or glycerol or methanol by itself, because I am wanting the mass of cylinder included with the mass of water for this particular lab. Okay, now in the other labs that we will do, you will have another data value, so you'll have the mass of the cylinder, and then you can subtract the two to get the mass of the liquid itself or the mass of whatever you are trying to measure. But in this particular lab, it's okay. So you will grab volume versus mass of water. And then I have a series of questions to go through. The first question, it tells you to graph using Excel, Google Sheets, or Desmos. Pick one of the 3. And you might need to look some of this information up or work with members of your group. For those of you who are going to be in my face-to-face course, you can work in your groups of 3 or 4 students. For those who are in my online courses, I am trying to set this up for the first time where you actually collaborate with each other. And that is partly why we're doing the Teams meetings this week, to introduce myself, first of all, to see your faces, but also to use the other people that have signed up in your slot to exchange your email information or whatever other information you want to share with each other, to be able to work on lab reports together. Now, as with any of my students, whether you're face-to-face or online, anything, you can collaborate together, you can work together, but you are still going to submit your own work, your own lab report individually, and you've got to make sure that you use your own words to do it. So copying the same, let's say there's 3 of you in a lab group, I don't want to see the same exact thing 3 times. Now, calculations make sense because you're using the same data, but when it comes to questions, those answers should be individual. So pick one of these. Some of you might have used one of these before in other classes, so if you're familiar, you might help some other students as well to get familiar with them. You might have to go to the internet to look some of this up. Okay, so the first one is you're going to have to know how to graph. For those of you who want to use Excel, I have a just general how to graph and how to extrapolate in Excel in the lab 1. So if you go to lab 1, we will do some graphing, and there's a video there that shows some of this, but not everything. So if you want to use that, you can as your starting point. Some of this stuff, though, you still have to figure out. And there's a ton of YouTube videos that would be you can find. Okay. You would need the title of the graph. So first of all, you would graph the data, title it, put it in the center, label the dependent and independent variable. So you are going to tell me which of these, the volume or the mass, is the independent and the dependent variables. So label them. Under B, you can just write them out, that's fine. And then on the graph itself, you will label the axis. So you'll say the y-axis is either mass or volume. The x-axis, you will label it as mass or volume, depending on which one goes where. And include the units. I have already given you the units here, so just please include them when you label a graph. This is very important when we do this kind of work in any science graphs, scientific graphs, or tables that we do construct. We have to use some of these units, especially with our labels. Then you find the best linear fit. So you're going to use trend line for Excel. You can do a search. Let me see if I can show you real quick here. So how to find a trend line in Excel. So there it is. And it will show you how to find the trend line with the equation. It will also, you can also add trend line in Excel with equation and R squared value. And it will tell you everything you need to know. So pick something, watch it, and then do it for your own graph. And you can also replace. So if you don't want Excel, you can just say Google Sheets, and it will give you this. You can do videos, so hit on videos, and there it is. All sorts of information. You can also do Desmos if you so choose. Desmos, I'm new to Desmos, so I have a little harder time with it, but I'm sure there, like I said, there are tons of videos on how to do all of this stuff on the internet. Okay. Then you include the y-axis intercept. So from the equation in part C, you can solve for the y-axis intercept and the x-axis intercept, so you can directly solve for D and E using the equation from part C. Include the slope of each graph. So what is the slope from the equation of the line? Give its physical significance. What is actually, so what does the slope of mass versus volume stand for? And then you can look up the literature value. I put mass versus volume slope here, but knowing what that is from part F here, you will be specific when you look up the literature value of the slope of each liquid to be able to get the value. So if you just type on the internet, what is the literature value for mass versus slope, volume slope of water, it's not going to know what you're looking for, because here I didn't want to give it away in G because I'm looking for a specific word in part F. If you, and then to find, once you find the literature value from the internet, then here's the formula you're going to use. So accepted value is also literature value, is called reference value. They mean the same thing. Experimental value is what you got from graphing your graphs with a particular slope, divided by the accepted value, which is what you look up on the internet, times 100. Now, if you see these vertical bars here, these mean absolute value. So no matter whether this, if you do this subtraction here, if this is a negative value, it doesn't really matter because the absolute value tells you that this answer should always be positive. So as a percent error, we never have a negative value. Okay. If you have questions on this, or if you want to make sure that your answers you're on the right track, you can always reach out to me. Make sure that you take pictures of your work, right? So if you're wanting me to see whether you've done something right, it is much easier for me to see a picture of what you're looking at, especially for those of you who are online, because I then see what you're seeing. It will save us a little bit of back and forth time in emails. Okay, that is sort of the overview for the first graph, or the first introductory lab.